In this section, we'll focus on Red Hat package management using RPM, the shell-based utility, which is responsible for installing, verifying, querying, upgrading, and uninstalling packages. Let's label this section RPM and describe briefly the features associated with this package manager. Provides package management, which includes but not limited to querying, which allows you to query your existing package database. And these are main functions, by the way. Installation, uninstallation, upgrade, as well as verification. These are the 5 major tasks you can perform with RPM. Again, to query the system means to consult the local RPM database to determine packages installed, as well as to query packages that have been downloaded locally or that are on DVD or CD-ROM or local media. Installation is just that. It allows you to install a package or more. Uninstallation removes packages. Upgrade upgrades existing packages. So if you have version 1 and you're upgrading to 1.5, 1.5 will supersede 1. And verify allows you to check packages as well as files on your system to determine if there has been any sort of compromise or if there are any discrepancies between the packages on your system and the original pristine sources provided by Red Hat or by a repository, an RPM repository. So RPM provides these sorts of features, and the main command is indeed RPM, lowercase of course. But depending on the mode that you intend to enter, you'll need to indicate whether or not you want to install, uninstall, upgrade, query, verify. We'll begin by querying, as it's easiest to determine what's on the system. So let's set up a query section. And a simple way to query the system is to execute RPM with the lowercase q option, which indicates query, followed by optional A, which will display all of the packages installed on the system. So dumps all installed packages from the RPM database. Again, RPM maintains a database on the system of installed packages. Also, we should note that most of the files on your Red Hat Enterprise system belong to a package. So you can query from those files using RPM query with the F option, query file, to determine package membership. So the files that you'll find, the overwhelming majority of them on your system, belong to a package, which keeps things organized and easy to trace. So let's execute this RPM query all. This is a quick way to determine what's installed on the system. We'll open a new shell. You don't need to be administrator or root to query the package database, but you do need to be root to install new packages, and we'll note that once we are in the installation section. So here you see a full enumeration of all the packages. It's still running. On a typical system, you'll find over 500, sometimes over 600 packages installed. To come up with a total count, use RPM query all and pipe the output to wc-l. So a variation on this command would be RPM query all, piping the output into wc-l. This dumps all packages and provides a count. Let's try that again. And momentarily we'll get a count. Also notice that the count is returned much quicker because the output isn't rendered to the screen. So there are almost 930 packages installed. From A to Z, the packages are dumped to the screen, and they cover everything from the X Windows environment, which includes GNOME, Xorg, and other programs to handle mouse, keyboard, and other interactions, such as to interface with your joystick, your audio card, so on and so forth, to MinGetty, which provides shell access via the different consoles, the different TTYs, to all of the programs that you use on your Red Hat Enterprise system. So this dumps and gives you a sense. You can pipe the output to sort so it's presented nicely, but we know that in this case there are over 920 packages installed. So query all gives you a sense. Now if you're searching for a specific package but you're unsure of the name, use RPM query all, pipe the output into grep, which is a line processor, because indeed each of the lines or each of the output that you see here are represented by lines. So we can grep each line one at a time, which is what grep will do. It takes as input one line to search for a match. So for example, let's search for the nano package. We'll RPM query all grep nano. Most packages are installed with the lowercase name, but if you're unclear or unsure, use the case-insensitive option of grep to search for the package. This will tell you if there are any instances of nano installed. Let's scroll down where this should be pasted. And there you see version 1.3 is installed with minor revisions made by Red Hat. So you can determine if a program is installed by searching for its package using grep to parse the output. Again, it's hard to determine based on the names and versions the exact name that you're to use, but usually the prefix such as nano will suffice. So if you RPM query and grep nano, it dumps it rather quickly. Or you could query info to determine whether or not. So for example, RPM query info nano will return information about the nano package. Let's just list that. So now that we know that nano is installed, RPM query info nano dumps info about the nano package. Whereas the previous example simply scoured the packages list to determine whether or not a package is installed. This is again similar to using, let's say, add remove programs in Windows and manually browsing the list to determine what's installed. So with query info, we see, for example, the name of the package, the version, the release. This is the Red Hat release of this major version 1.3 with minor release 12 by the vendor. Red Hat is the vendor, although Red Hat isn't the author. The date it was built, so this package has been around for a while. The install date. The group, each package belongs to a group. In this case, it's applications/editors. Its size, it's just over a megabyte. The type of license which governs the package. Its signature, which includes a key ID. Each package is signed by Red Hat and can be verified, and in fact all of the packages included on the installation DVD or CD set are signed and are verified by default when you install them using the RPM program. It's another feature provided by RPM, where you may find out more information about the nano editor, a summary, and an optional description, which includes the fact that it's a small text editor. So another feature of RPM is the fact that it auto-verifies packages using GPG, MD5, SHA-1 sums. So this is taken care of for you. By default, packages released by Red Hat Inc. are signed with the appropriate GPG key, which we can use on our system to verify packages independently of the installation process. So we know how to query the entire system. We know how to get a count of the number of packages. We also know how to search for a package if we're unclear of the exact name. We know how to interrogate the package from the package database to see what it provides, its version, when it was built, so on and so forth. And we know how to get some basic information, but there's still more information that we can get about packages. Additionally, let's compare and contrast. This system, the LinkCBT Serve 1, is running Red Hat Enterprise 5. But we've got a remote system which is running 5.1. So let's SSH to 168.75.199. And this system, if we cat etc Red Hat release, you see that it's running 5.1. So the version of Nano is likely to be slightly newer. We know that from the local system, the version is 1.3.12, release 1.1. So on the remote system, let's RPM query info nano as we're assuming that it's installed. And we see indeed it's 1.3.12, release 1.1, indicating that it's the same version of Nano, which with a build date of the 12th of July 2006. So although this is a slightly newer version of Red Hat Enterprise version 5, major version 5, the same version of Nano is used, which indicates that Nano had not changed between the two releases. Again, 5.1 includes some updates, some fixes, some tweaks, as you'd expect with a service pack release of any operating system. Super. So that's how you query a package. Now, how about querying files on the system? We've been working with Nano. How about querying to determine a file's package membership? So the fifth step, RPM query file, and we need to determine where Nano is located, which is why we'll use one of those trusty commands we studied, the which command, to determine where Nano is available, and it's in user bin. So an RPM query file, user bin, Nano, dumps package membership information for the Nano file. So in other words, this is a reverse lookup using the file to determine what package the file belongs to. Again, most if not all programs you'll find on your system, unless the program was introduced outside of the RPM framework, belong to some RPM. So let's go ahead and give this a query, and now we're able to tell that the user bin Nano the user bin Nano file belongs to Nano-1.3, so on and so forth. So this is a reverse way to look things up. Let's look something else up. Which grep, for example. RPM query file bin grep tells us that it belongs to this version of grep. How about the which command? Well, let's execute which, and it tells us it's an alias, but which is really located in user bin. So an RPM query file, user bin which, will tell us momentarily the membership, which belongs to a distinct package named which. So you can tell from the file itself the package membership, because when you execute query file, RPM simply looks up the matching file in its database and determines whether or not the file belongs to an item on file or a package that's on file. You may also query a package before you install it. We intend to install a few packages, but you can download the package and query it directly. For example, we do have a package repository available, a 5.1 package repository, but the 5.1 packages will install on 5.0 with no problem. Let's launch an instance of the browser and then connect to that repository and select a package that's currently not installed on either Linux CBT Serve 4 or 1. Either or will do. And we'll now navigate to 192, 75.100 RH5, i386, server. This is where we can find the different packages, and once there we'll bookmark it so that we can reference it. It'll be placed in the main area, and the full list will be ready momentarily, at which point we'll scroll down and search for something that we believe is not installed on either system, and that's the DHCP package, not the client but the server. So here's the package. If you copy the URL using copy link location, it includes the full HTTP location to the package. We can then, from the shell, paste this information as follows: RPM query package info, the full URL. In this way, we're able to tell information about the package prior to installation. So the RPM query package info as opposed to query info. Query info queries packages in the database. So it dumps information about the Nano package as it's recorded in the local RPM database. However, as a sixth option, RPM query package info followed by the URL that we've just pasted dumps info about the uninstalled DHCP package which resides on the repository. That's the HTTP repository. The information is similar to what you'd see when you execute RPM query info against a package that's locally installed. It includes the name, the version, the release by Red Hat, the vendor, the build date, the install date. It's currently not installed. The build host. Usually it's a box at Red Hat. Other important information: size, the group where the package belongs, the source RPM or the RPM package that was used to create this package, the binary RPM, the packager, the signature, description, summary, so on and so forth. So you can query a package before installation. That's the purpose of using the RPM query package info options. Now again, no need to memorize all of these commands. Ideally from the shell, if you can execute RPM followed by -- help, you'll see the myriad options that are available, including query, freshening, the --F option, upgrade, installation, removal, and other options. The RPM package, or the RPM program, offers many, many such options. Now let's move on to verification. You can verify all of the packages on your system quite easily using RPM uppercase V followed by lowercase a. Uppercase V means to RPM that it's to verify whether it's the packages in your database, the RPM database, or a package on your file system or on a remote file system such as an HTTP accessible location. So verify all navigates through your database, checking all, in our case, 929 packages to determine whether or not the integrity of the packages are intact. In other words, to ensure that what was installed is what is actually reflected on our local system. This is a quick way to determine whether or not packages have been upgraded, changed, or tampered with. Only if there are issues that don't reflect the original system configuration will you see output. So for example, what we see here is some output related to items that were created as a consequence of installation. So these are additional items, like the etc.ssh moduli file, for example. These messages are perfectly fine. We'll let them come back. However, if you see any discrepancies related to a package, specific package, let's say nano, such as a signature issue, an MD5, SHA-1, or signature issue, GPG issue, then you know you've got a problem. There's some sort of compromise or change to that package on your system. So the general VA option scours all 929 packages or the full package database to determine if there are any problems. And if there are any blaring issues, you'll see them on the screen. These are small. These usually reflect files that are created as a result of package installation and are generally not important. You may also verify files directly, such as, let's say, grep. And let's just indicate that this verifies all packages on the system, returning information only if there are discrepancies from the original installation. Now to verify a file, RPM-V, uppercase V, that is lowercase f, just like you'd use when querying a file directly, followed by the path to the file, such as user bin nano. This will verify whether or not nano has changed. Again, the verification process takes into account GPG as well as SHA-1 and MD5 technologies. Now let's just kill this full verification for a moment so that we can reuse the shell. We use Control-C to kill it. Clear screen, and then RPM verify the nano package. And if no output is returned, that means the package has passed the test. However, if we were to compromise the user bin nano file purposely and then attempt to verify the file, the RPM verification process would detect a change based on one or more attributes such as MD5, the file size, whether or not the mode or permissions has changed, and so on. So, task change user bin nano, then verify. So to do so, we'll move the existing copy of nano. Let's SU in first, however, as we'll need full rights to be able to do so. Then navigate to user bin. So we'll move nano to nano.old. Then we'll sequence 1,000,000 nano. And even if we were to create a nano file that's the exact size of the original binary, and even if we made it binary using DD, for example, RPM verification would be able to detect the difference or the discrepancy. So now using RPM uppercase V lower f followed by user bin nano, you'll see that it'll pick it up momentarily. Now we see some output. And what does this all mean? Well, let's copy it and translate. So this returns SM5, a bunch of dots, T for the file. Well, there are various status codes that may be returned, and this is included in the RPM documentation. S means the file's size has changed from what was or what is in the database. So in the RPM database is an entry for the file user bin nano, and the verification process is telling us or has told us that the size no longer matches. M means the mode or permissions have changed. So mode or permissions. For example, maybe the original file was flagged 755 and now it may be flagged 644, so on and so forth. 5 means the MD5 sum no longer checks out. And T means that the modification time is no longer the same as what is recorded in the RPM database. So there it tells us that there's a problem. Now let's echo the exit status. You see that it's non-zero, indicating that the verification process encountered a problem. To rectify the situation, we'll remove RF nano, that's the new corrupt version of nano, and then move nano.old back to nano, then rerun RPM verification against nano. Now the exit status is 0, everything looks clean. So you can use RPM to determine whether or not any of the RPM related files have changed. Now again, we did mention that each entry is maintained in the RPM database. You can RPM query list, for example, nano, to see the contents of each package, of which you'll also find the nano binary user bin. And within the RPM database are fields, important fields such as size, MD5 sum, whether or not it's a symlink, modification time, the mode, user and group, so on and so forth. All that information is stored within the package, and that's how RPM is able to check and to determine whether or not anything's changed with a file. So that's how you go about using the verification process to verify files. You may also verify packages using the uppercase V and lowercase p options. So for example, RPM VP nano will attempt to perform a verification on nano against what's installed on the system. In this case, we need an RPM, so we could link to the original RPM, wherever it happens to be. If you just do VP nano, nothing's returned. However, if you specify a source, such as the one in our Firefox browser, let's find nano here, and copy the link location, then attempt to RPM VP the link location, this performs a test against it, and it determines if there are any issues. A warning was returned, however. How about on the remote system? If we RPM VP, just to see if there are any differences, and it returns a warning as well for this version of nano. Now let's move on to another mode of using RPM, and that's to install packages. We execute an installation using the I option. That's lowercase I. You may optionally turn on verbosity, which is lowercase v, and hash marks using H, followed by the name of the package, one or more, and RPM will attempt to install the package. Now, RPM automatically handles dependencies, so let's list that as a third feature. Automatically reports on unresolved dependencies. So it knows, based on the contents of the package that you're trying to install, the other packages that are required for successful operation of the package you intend to use, and will report to you as such. So if you try to install a program or a package which depends on another package or program, RPM will complain, indicating that you'll need to install the other package, which you can do on the command line along with the original package. We need to find programs to install, by the way, so let's take a look at our package repository. We'll just Alt-Tab, and we'll install that DHCP package. This is the server package. We'll uninstall it in the removal section momentarily. So we'll copy link location again. Just make sure Firefox is in view, and then from the shell we'll use RPM and specify the HTTP URL. Again, we need to be root in order to do so. Now we're installing this on a remote system. That's fine. It will install just as well, and it will also install locally. IVH followed by the name of the package does the trick. If all goes well, the package is installed. And a warning was thrown because we had no key, or we don't have the GPG key imported. It's not imported by default. And a warning was thrown for the verification as well because of the same reason. So as an example, RPM IVH installs packages. However, the installation process overwrites, or does not overwrite previous, whereas the upgrade process overwrites. So install does not overwrite previous package. And this is why the installation method, which means using the lowercase I option, is the proper method or ideal method for installing the kernel. So note, use this method to install a new version of the kernel. So if you get a new kernel package from the Red Hat network or from a Yum repository, use IVH instead of UVH, which we've yet to look at, because the installation option indicated by I ensures that the package is not overwritten, meaning an existing version of the package is not overwritten. So if we had, let's say, version 2.6.13 of the kernel and we receive 2.6.14, 2.6.13 will not be removed. So installing a program is very easy, especially when there are no unresolved dependencies. We see the hash marks for preparation and installation, and once it's been installed, it's available for querying locally using RPM query. In this case, the package's name is DHCP, and it returns information. It tells you when it was installed, which is today's date, and the fact that it's available. If you want to see the files within the package, RPM query list DHCP will do the trick. It includes all of the packages in, or all of the files that is in that package, and is indeed another query option that you'll use quite often. So let's just list it as a 7th query option. RPM query list package name returns all included files, which also includes any directories that are created by the package. So keep that in mind. So again, installation will not overwrite a previous version of the package. It simply makes the program available and you're free to use it. Let's find something else to install. Let's determine whether or not GFTP, which is a graphical FTP program, is installed using RPM query all grep case insensitive GFTP. It's currently not installed, so the exit status is non-zero. Let's navigate to the browser and get a URL for it. We'll Control F to search for GFTP. Here's the package, version 2.0.18. We'll copy link location, and then on a remote system execute RPM IVH and the full path. This will install GFTP. It doesn't need any additional packages. So now a which GFTP tells us that it's installed. An RPM query file user bin GFTP tells us that GFTP belongs to GFTP. So it's installed. So IDH is a really simple usage of the RPM program. There's yet another mode that we have not explored, and that's the upgrade option. This overwrites an existing version. So upgrade installs or overwrites existing package. So use this if you want to install fresh or overwrite an existing version. The usage is just like what we showed you for installation. Instead of I, however, you specify U. So RPM UVH for both cases, and it'll overwrite or install fresh anew the package that you have of interest. So for example, if we wanted to install GFTP on our local system, we'll take the URL we just posted, and that's the entire path, that is. We'll copy it, and locally we'll execute it, but changing I to UVH. GFTP is currently not installed on the local system, and this is upper U, so let's go ahead. And now it installs it. Let's just note that as well locally, that it's upper U and not lower U. That was a slight oversight. It's actually uppercase U. So this will either upgrade the package or install it anew. Now locally, RPM query all grep GFTP reveals that it's installed, and in RPM, once this comes back, query info GFTP will reveal that it was installed today in the installation date field. So UVH is what you use when you want to overwrite or install anew. There's yet another option. That's the ability to freshen a package. This simply updates an existing package. However, the freshen option will not install the package if it does not exist. So note, will not install the package if it does not exist locally, meaning it has to be installed for it to work, and it uses the uppercase F option. So RPM FVH start at RPM freshens the current version of a package to whatever version you've specified. So you'd have to search for something local. Let's see, for example, if we RPM query list grep or RPM query info grep, this will tell us the version of grep that's installed and when it was built. November 27, 2006. Chances are 54.2 will not have changed with 5.1, and we can just double check that. And it's still 54.2, so it hasn't changed, so it doesn't make sense to attempt to install what's already there. Freshen wouldn't work in this particular instance. We'd have to have a newer version of the package. But just bear in mind that freshen, although we didn't specify it as one of the main 5 options, is a way to install or upgrade a package in the event that the package currently exists on the system. Now how about package removal? That's very straightforward as well. RPM-E with optional VH for the verbosity and hash marks, followed by star RPM, removes a package. However, the removal process takes into account dependencies. So if it sees that by removing the package you'll break other packages, it will complain. So let's just note, removal process considers dependencies and will complain if the removal will break one or more packages. To get around this, use the no deps option or no dependencies option with RPM EVH. So RPM EVH no deps followed by the RPM, the name of the package, will remove it without regards for dependencies. So with that said, let's remove GFTP using RPM EVH GFTP. to dump GFTP. Now there are no other packages that depend upon GFTP, so we should have no trouble removing it from the local system. And here it throws an error because we attempted to use the hash mark with the removal, which is fine. So we'll just dump it. Let's take it from our documentation. And this version of RPM supports the hash marks only with installation, which includes upgrades as well. Now let's confirm that RPM performed the way we expected it to using RPM query all grep GFTP, and we should see nothing returned, indicating that the package doesn't exist. It's been removed. Let's remove it from the remote system as well. RPM EV GFTP as well as DHCP. And if the package isn't installed, it tells you, it returns an error, and it's gone. So removal is pretty straightforward, but again, if there are dependencies, RPM will complain, and in order to force a removal, you'll need to use the -- no deps option. So thus far we've covered installation, querying, verification, upgrading, removal. We haven't freshened the package because we currently don't have a newer version of a package. Perhaps later on, if we find a version of a program which supersedes an existing version, then we can freshen the package, but it's pretty straightforward. Just use uppercase F with the lowercase VH option for verbosity and hash marks, and an existing package will be freshened. Use UVH to upgrade or install a new, and use IVH to install a new version without overriding an existing version, such as when you're installing a new version of the kernel. Now there are other ways to integrate package installation into your Red Hat environment, such as using Yum, as well as using the graphical environment. The graphical environment is available from the Add Remove section, Add Remove software in the environment. You may also access it using system config packages. So let's just note Package Management GUI. 1. Use Add Remove software, which really is a pointer to system config packages. So again, applications, Add Remove software, or from the shell, and it's a self-explanatory, straightforward GUI, execute system config packages, which brings up the same GUI. We'll see it momentarily. Straightforward interface. It did report in the background that the system is not registered with RHN, which means newer versions of packages will not be downloaded, but that can be fixed with Yum, providing we set up an internal package repository. So here are all of the packages that are available. You may filter the list to installed packages, and the items that have checks next to them are installed. You may also look at available packages, packages that you may install. Since there is no formal package repository defined, we won't see a list. By default, the System Config Packages utility will check the Red Hat network. However, you need to be registered with the Red Hat network to take advantage of it. And since we are not, we cannot use it. This list here represents everything that's currently installed on the system. You can search for packages, and if you have a repository defined, items will be returned, and you may also browse if you have a repository defined. Again, the GUI interface is pretty limited, as we have often found with many of Red Hat's GUI interfaces. They're generally very limited, unlike SUSE's GUI interfaces. However, it still provides some sort of window into your programs. We suggest you typically use RPM, the shell-based tools, to support installation, removal, and management of packages, as the GUIs tend to be anemic with Red Hat, and they tend to change quite often from version to version. So that's a little bit about the GUI interface. What we want to look at next is Yum, a way that we can actually configure a repository that our internal systems can use to query. If you notice, when we launch the packages interface, it says it's not registered with RHN and the support will be disabled, which is why we're unable to browse and search for new packages. No repositories were set up. However, when Yum's in place, that changes the presentation in the GUI.